I, S. Sripathy, applying for the position of Assistant Professor in Mechanical Engineering Department, Kids Warangal. I thank Management, Principal, HODs, Dean for giving this opportunity. About myself, I, S. Sripathy, did my BTech Mechanical Engineering from Vijay Rural Engineering College, Nizamabad, affiliated to JNTU, Hyderabad. I did my MTech in Design Engineering specialization from KITS Warangal. Presently, I am pursuing my PhD as a part-time scholar in Usmania University in the field of composite materials. I have 13 years of teaching experience. I have worked 1 year in VMR Polytechnic College and 2 years in Warangal Institute of Technology Science, Warangal, as lecturer. And presently I am working as assistant professor in mechanical engineering department, Kids Warangal. Today's my topic is on bearings classification and types of rolling contact bearings for BTech students. The learning objectives of the today's session topic is, by this session the students will develop knowledge in understanding the types of bearing and will be able to list the guidelines for the selection of bearing types. And student will gain the knowledge in classification of rolling contact bearings, applying the guidelines for selection of bearing life and load factor. Prerequisite for this topic are engineering mechanics, strength of materials, engineering materials. Bearings. Bearing is a mechanical element that permits relative motion between two parts such as the shaft and the housing with minimum friction. The function of the bearings are as follows. The bearing ensures free rotation of the shaft or the axle with minimum friction. The bearing supports the shaft or the axle and holds it in the correct position. The bearing takes up the forces that act on the shaft or the axle and transmits them to the frame or the foundation. Bearings are classified in different ways, mainly depending upon the direction of force and type of friction. Depending upon the direction of forces that acts on them, bearings are classified into again two categories. One is radial, there is thrust bearing. From the figure 1A, you can find a radial bearing where the force is acting perpendicular to the axis of rotation of the shaft. That is radial bearing. Now coming to thrust bearing, from the figure, you can find the force acting along the axis of the shaft's rotation, and this is called as the thrust bearing. And coming to other type, depending upon the type of friction between the shaft and the bearing surfaces, they are classified again into two main groups. One is sliding contact bearing, second one is rolling contact bearing. Now coming to sliding contact bearings, the sliding contact bearings are also called as plain bearings or journal bearings or sleeve bearings. In this case, the surface of the shaft slides over the surface of the bush, resulting in friction and wear. In order to reduce the friction, these two surfaces are separated by a film of lubricating oil. The bush is made of special bearing material like white metal bronze. Here you can find the shaft inside rotating inside the bush, and between you can find the lubricating oil, which is intended to reduce the friction between the surfaces. The sliding contact bearings are used in following applications like crankshaft bearings in petrol and diesel engines, centrifugal pumps, large size electric motors, steam and gas turbines, and concrete mixers, rope conveyors, and marine installations. Coming to rolling contact bearings, rolling contact bearings are classified, are also called as anti-friction bearings or simply ball bearings. Rolling elements such as Balls or rollers are introduced between the surfaces that are in relative motion. In this type of bearing, sliding friction is replaced by rolling friction. The rolling contact bearings are used in following applications like machine tool spindles, automobile front and rear axles, gearboxes, small size electric motors, rope sheaves, crane hooks and hoisting drums. Here you can find in the place of between the shaft and the bush, the space is occupied with the small rollers. They may be of ball rollers or cylindrical rollers. Here is the shaft and the bush. In between you can find the rolling elements, that is ball rollers or cylindrical rollers. Coming to rolling contact bearings, in rolling contact bearings, the contact between the bearing surfaces in rolling is rolling instead of sliding as in sliding contact bearing. Ordinary sliding bearing starts from rest with practically metal to metal contact. In sliding bearing, you can find the shaft and the bush are practically metal to metal contact initially. It is an outstanding advantage of a rolling contact bearing over a sliding bearing that it has a low starting friction. You can find less friction in the rolling contact bearing when compared with the sliding contact bearing. Due to this low friction offered by the rolling contact bearings, these are also called as anti-friction bearing. But this is misnomer because although at the starting of the friction in sliding contact bearing may be more than the rolling contact bearing. But when the condition of the full hydrodynamic lubrication is attained in sliding contact bearing, the running friction may be quite less as compared to rolling contact bearing. Okay, from this graph where speed of the shaft versus friction between the bearings, when you observe for here general bearings initially are having high friction. As the speed increases, the general bearings will be having less friction when compared with roller or ball bearings. The advantages and disadvantages of rolling contact bearing over sliding contact bearing are: the advantages: low starting and low running friction. Low friction can be obtained in case of sliding bearing in case of full film lubrication. It is possible in hydrostatic lubrication and it is very costly. Static sliding bearing is initially it costs very much. Now other advantages of rolling bearing is ability to withstand momentary shock loads without failure, accuracy of shaft alignment, low cost of maintenance as no lubrication is required while in service. Rolling bearing gives warning prior to failure, whereas sliding bearing failure is sudden and hence more dangerous compared to roller bearing. Reliability of the service is one of the advantages of rolling contact bearing. Easy to mount and erect and cleanliness. Coming to disadvantages, more noisy at very high speeds, low resistance to shock loading, more initial cost, design of bearing housing complicated. Now coming to classification of rolling contact bearings based on the shape of the rolling element, that is there are two types: ball bearing, roller bearings, in which the roller in ball bearing in which the rolling element are in the form of spherical balls. Roller bearings in which the rolling elements in the form of rollers, which may be cylindrical, conical, spherical or needle in form. You can find here from the figure the ball bearing, a spherical ball is in between the outer race and inner race. Whereas in roller bearing you can find a cylinder or a conical or needle form of bearing between the outer race and inner race. Here the roller you can find. Based on the nature of loads resisted by the bearings, we have other classification: radial bearing, angular contact bearing, thrust bearing. Radial bearings, these bearings resist primarily radial loads with low magnitude of thrust load. Angular contact bearings, these are used where loads are combined radial and high thrust load, for which taper roller or conical and spherical roller bearings are considered as angular contact bearings. Now thrust bearings, these bearings resist loads which are primarily thrust in nature. Coming to types of ball bearings, we have single row deep groove ball bearing, where here in figure, from the figure you can find the outer race, inner race, between you can find these ball bearings rested in the grooves. Double row ball bearing. Here from this figure, this is a double row ball bearing where you can find outer race, inner race, and in between you can find these balls being rested in the grooves. Double row ball bearings have two rows of balls arranged back to back. This means the bearings are particularly suitable for accommodating simultaneously acting radial load and axial load in both directions. They are also available with seals and or shields. Now coming to angular contact ball bearings are non-separable type bearings and typically used for carrying combined loads, that is axial and radial load. They can carry pure axial load and operate in higher speed. That's why many people refer to them incorrectly as thrust bearings. The advantage is they can carry pure axial load and operate in higher speed. Here you can find this angular contact ball bearing, outer ring face and inner ring back face. Between them you can find these balls between the races, where this can accommodate the design of this outer race and inner race can accommodate for axial loads also. Self-aligning ball bearing. In this bearing, the outer race is a part of allosphere which permits the bearing to have self-alignment property. This feature permits angular displacement of the shaft relative to the housing. Further, in these two rows of balls are arranged in zigzag manner and is used for radial loads. Here you can find the self-aligning ball bearing which permits the shaft for self-aligning. Now thrust ball bearing. These are designated to resist axial loads but not radial loads. In these, balls are placed between grooved rings called washers. Here you can find between these two rings the ball bearings are placed between these two rings. Now coming to types of roller bearings, we can see needle bearings and spherical roller bearings. In these rollers, are used while length is at least 4 times the diameter. Here the rollers which we use are having the length equal to the diameter of the roller, which we name them as a needle bearing. These are used where space is limited. These are amenable with or without inner race. As the number of roller goes up, the greater the contact area. As the number of rollers are increased, the area of contact will be also increased. The greater the contact area, the greater is the load taken. Now coming to spherical roller bearings. These contain two rows of roller in barrel of spherical shape. You can find them here. These can resist heavy radial loads and moderate thrust loads combined with the ability to run properly under condition of misalignment. Tapered roller bearing. These are rollers in the form of truncated cones. Cylindrical roller bearing. These are bearings having short rollers guided in a cage. Parts of ball bearing. It consists of four elements